Hi everyone, welcome to Simplilearn. Today I am going to discuss about Docker versus Kubernetes. Let me take you to the agenda for today's session. So today first I am going to start with what is Docker, then what is Kubernetes, then what are the Docker use cases we have, then what are the use cases of Kubernetes, then are the Docker and Kubernetes are competitor, then we have how they work together. So Docker and Kubernetes differences. After that, architecture of Docker and Kubernetes. Then CLI, that is command line interface and tooling differences. Then how we are going to deploy a workflow for the comparison, right? Then we have when to use Docker, when you need a Kubernetes, then what are the alternative to Kubernetes, then what are the misconceptions we have, then future of Docker and Kubernetes. After that, we have a recap, then which one you should learn first, right? So these are the topics what I'm going to discuss in today's session. Now, let me take you to the first slide of today's session. What is Docker, right? So here you can see Docker is a containerization platform that allows developers to package application and their dependency into a single unit called container. Now, Docker is a containerization platform. It packages your application and all the dependencies like libraries, configurations, runtime into a single portable unit called containers, right? Now, to explain more about this, if I consider one simple example, let us consider a developer builds a Python web application, right? So now instead of worrying about the system dependency on a different machines, they package it into the Docker image. Anyone can run it using the particular Docker file, right? Let me take a simple scenario. Now you are developing one Flash application on Windows, but now you want to deploy it on a Linux in AWS EC2 machine, right? So now Docker ensures it runs identically everywhere. So that is the power of Docker now. Now, let's move on to the next slide. What is Kubernetes? So, Kubernetes or K8 is a container orchestration platform that helps you to manage, scale, and automate container deployment efficiently. So, now Kubernetes is a container orchestration system. It manages, scales, and even automates the deployment of multiple containers. So now, to explain more about this, let me take one simple example here. Let us consider if your application uses a 10 Docker container for a backend, front end, and database. So Kubernetes can automatically distribute them across the servers, right? And even it restarts the failed containers and balance the traffic, right? Let me take one simple scenario. Let us consider your e-commerce site need to scale during especially sales, right? So Kubernetes will automatically add some pods, containers, and removes them after a traffic drop, right? Okay. Now let's move on to the next slide of Docker use cases. In this slide, I am going to discuss about some of the use cases of Docker. In that, the first one is local development. So Docker provides the consistent environment for developers. Instead of setting up a dependency manually on every system like Node, Java, Python, etc. So Docker containers include everything that application required. For example, code, libraries, configuration, everything, right? Now, if I take one simple example for this use case, let us consider a developer is building some Node.js web application that required a Node 18, MongoDB, and even Redis database, right? So now, instead of installing all locally, they can use a Docker compose.yaml file, right? This is one simple example I can consider for local development. Let me take one simple scenario. So, you and your teammate work on the same application, right? One on Windows, another on Mac. So Docker ensure the both uses the same setup, same operating system, same version to avoid a compatibility issue. So this is one simple scenario you can consider for local development, right? Now let me take you to the next point. Isolated environment. So isolated environment means that each Docker container runs independently without its own file system, processes and network, completely separated from other container and the other operating system. In simple words, whatever happens inside the one container does not affect the another container or your host machine. Let me take one real world analogy for this. Think of your computer as apartment building and each Docker container has a separate flat. Each flat has its own kitchen, bathroom and electricity, right? Like its processes, file system and a network, right? Now, tenants. Tenants are application. Can't mess with each other's room unless you connect them through a shared hallway. That is Docker network. So the building owner is nothing but Docker engine that manages all the flats. Now, let me take you to the next use case of Docker testing and CI/CD. So now CI/CD pipelines. Docker standardize builds and deployments, making it perfect for continuous integration and continuous deployment. So in CI/CD systems like Jenkins, GitLab, then AWS code pipeline, each build or test job can run in a clean Docker container. Even it ensures the repeatability. Now, let me take some scenario where I'm going to use the CI/CD pipeline. So let us consider I want to build the Docker image of my application, right? And I want to do I want to run some automated test in that container, like pushing the image to the ECR, that is Elastic Container Registry, and deploying the same images to AWS ECS or Kubernetes, right? So by using this, you are ensuring that the same container tested in the another running in a or a production environment, right? Now, let me take you to the next use case of Docker, microservices. So Docker makes it easy to build and run microservices, where each service runs independently in its own container. So instead of deploying one big monolithic application, you are going to split this functionality. For example, authentication is separate, payment is separate, and even notification is separate. And now you are making into the smaller, independently deployable services, right? Now let me take one simple example. Let us consider I have an e-commerce application, right? So now this e-commerce application can have the multiple modules like authentication service for user login purpose, that is container A, then catalog services, that is for product details, container B, then order services, order processing system, that is container C. Now these all containers can be run on a host using a Docker Compose or a scaled across the servers using Kubernetes, right? So now let me take a simple scenario. You can update the order services containers independently without redeploying the whole application, right? So by using this, it improves the agility and also uptime, right? So these all are the Docker use cases just now what I discussed with you people. Now, let me take you to the next slide where I'm going to discuss about the Kubernetes use cases. So in that, the first one is multi-container orchestration. So Kubernetes is an orchestrator. It manages how multiple containers, that is nothing but microservices, work together across the several nodes. So now Kubernetes decides where each container runs. That is nothing but scheduling. How they communicate using networking. What is the DNS? How much resources each gets, like CPU, memory, how they are updated or restarted. Overall lifecycle management. So instead of you manually starting the containers on each server, Kubernetes will automatically all perform this task, right? Let me take one simple example. You have one web application with front-end React, then backend API Node.js, then I have a database called MongoDB and Redis caching, right? So you are going to define this all in YAML manifest. So the Kubernetes that deploy each as separate pods. Then it connect them via internet service network. And apart from this, it ensures the dependencies starts in the right order, right? Let me take one simple scenario now. In a microservice based e-commerce application, Kubernetes orchestrate 20 plus services like users, cart, payment, catalog. If one service needs more CPU, so now K8 schedule it on a different node, automatically balancing the workload, right? Now, the next use case is auto scaling. So Kubernetes can automatically increase or decrease the number of running pods based on demand or load. So this ensures the optimal performance and cost efficiency. So now Kubernetes uses horizontal pod autoscaler, that is HPA, to adjust the number of pods based on metrics like CPU, memory, or custom metrics. Then we have another option called cluster autoscaler, where you can add or remove the worker nodes if pods can't be scheduled due to lack of resources. Now, let me take you to the next use case called rolling updates and rollback. So now Kubernetes can deploy a new version of your applications gradually, replacing old pods one by one. This is a rolling update. If something goes wrong, it can be instantly revert to the stable version. That is nothing but rollback. So here it enables a zero downtime deployment in a production environment. Now, let me take a scenario. A streaming company pushes some new API versions. So users never notice a downtime during this rollout. When a bug causes login error, so K8 automatically rollbacks to the previous version. So that is the power of one of the use case called rollback. Now, let me take you to the next use case of Kubernetes, that is fault tolerance. Even we are calling it as a self-healing. So Kubernetes is self-healing. It constantly monitors the health of nodes and pods. If container crashes, node fails, or pod becomes unresponsive, Kubernetes automatically replaces or reschedules at elsewhere, right? So what are the core mechanisms we have in this Kubernetes? Like liveness and readiness probes, which detects unhealthy containers. Then replica sets ensures a fixed number of pods always run. And then we have a node controller. So it replicas the pods from a fade. Now, let me take a simple example. Let us consider you are defining replicas as 3. Now, if one pod crashes, Kubernetes will immediately start a new pod to maintain the 3 active instances. If worker node goes down offline, Kubernetes will reschedule its pods onto healthy nodes. Now, let me take a simple scenario. Now, I have a fintech application. If one EC2 node in the cluster fails, Kubernetes will automatically shift that running pods to another node. So user never experience a downtime. These all are the use cases of Kubernetes. Just now what I discussed with you people. Now let me take you to the next slide. Are Docker and Kubernetes are competitor? So in simple answer is no. Because Docker creates a container. Kubernetes organize and manages. So Docker create and package the container. Kubernetes runs, scale and manages those containers at production scale, right? Now, let me discuss what is the role of Docker. So Docker, the purpose of Docker is to build reproducible container images. That is nothing but application plus runtime plus libraries. So what is the output? A container images, which is stored in registry. So registry means whether you can store in Docker Hub, Amazon ECR service, Elastic Container Registry, or etc. Then what are the typical tools are available? We have Docker build, Docker run, Docker file, and even build kit. Now, if I talk about the Kubernetes, At the next slide, orchestration layer. So what is the purpose of this Kubernetes? You can deploy, you can scale, heal, and manage your container across the cluster of machine. So what is the input now? Container images, OCR, which is pulled from a registry. So here, typically, you can use some tools like deployment services, replica sets, stateful sets, persistent volumes, configure maps, and even secrets. So these are the inputs you can consider as a tools you can consider for your Kubernetes orchestration layer. Now, let me consider one simple example where developer builds a image that is nothing but Docker file, right? So once your Docker file is ready, you are going to push that images to registry, right? After this, Kubernetes will come into the picture where Kubernetes pulls and runs that images in the deployment environment. Fine. Then it exposes the application that is nothing but services, right? After that, updating like rolling update or rollback, right? So these are the steps you can consider for this simple example. Now, why this is powerful? When you combine these Docker and Kubernetes, what benefits you will get? In that, the first one, I can say that immutable ways. So the exact same container image you tested locally, right? So what runs in a production environment, right? Then portability. Docker images compliant. Kubernetes can run them across the clouds or on-premises environment. Then automation. Kubernetes adds auto-scaling, self-healing, service discovery, rolling updates, and persistent storage, right? Let me consider one simple analogy to understand a Docker and Kubernetes. So Docker, the packaging and shipping factory that produces sealed boxes, that is nothing but images. Now Kubernetes, a warehouse plus logistic company that stores boxes, route them to the stores, scales stores up when busy, and replace the damaged boxes across the fleet of warehouses. Okay, now let me take you to the next slide where I'm going to discuss about how Docker and Kubernetes works, right? So here I have Docker and Kubernetes where I have some container images, right? So first, Docker creates a container. Kubernetes organize and manage them. It means Docker handles the packaging part, that is building a container images, and Kubernetes handles that deployment, scaling, and management part, which is running containers reliably in the cluster, right? Now, first, developer. Developer builds a image using Docker, right? So developer write a application code and make a Docker file. So now this Docker takes that a code and package it with all the dependencies and libraries into the container images, right? Now, so these Docker images is pushed to container registry. Once tested locally, the image is uploaded to the container registry. So it's a centralized store for images. Now you can store these images in Docker Hub or Amazon ECR, that is Elastic Container Registry, right? After this, Kubernetes will pull that Docker images. Kubernetes doesn't build the container, it uses them. In a Kubernetes cluster, right, it uses the container images to deploy and manage containers. So here you are defining a deployment YAML, that is configuration file, that telling Kubernetes with the Docker image to use. So how many replicas to run and what ports to expose, right? So now Kubernetes will pull the Docker image from a Docker Hub and run in ports inside the cluster, right? So now Kubernetes will manage the containers, that is nothing but pods. So if your application is running in a container, that Kubernetes can handle the operations like scheduling, where you are going to decide which node in which virtual machine each container should run on. Then scaling, right? Scaling, increasing or decreasing the replicas depending on the traffic. Load balancing, distributing a request even across the ports. Self-filling, restarting the crashed containers or moving them to healthy nodes. And even updates, performing some rolling updates to the new version with zero downtime. So now Kubernetes will ensure that your containers are always running, healthy and reachable without you having to manually managing a servers. Now, let me take one simple real life scenario. Okay. Now the company is online food delivery application. So what are the things you have to set up now? Docker. So Docker is used by developer to build a container for each microservices. For example, we have order services, payment services, restaurant services, and even delivery tracking services. So each image is stored in Docker Hub or ECR service. So now Kubernetes uses to deploy these Docker images. And even here you are going to define a deployment, auto scaling, rolling updates, everything, right? Now let us consider if order services suddenly gets more requests. So Kubernetes will automatically scale it from 3 pod to 10 pods. If one pod fails, Kubernetes will replace it automatically. That is the power of Kubernetes, right? So Docker, it ensures the consistency across the environment, and Kubernetes is ensure the reliability and scalability in production environment, right? Now, to understand in a better way, let me take one simple analogy. Docker is like a shipping container manufacturer. It creates a container that holds goods. That is nothing but application. Kubernetes, as a part of logistics system, it decides how to load, unload, and distribute those containers efficiently. So Docker packages, Kubernetes orchestrates. So this is all about how your Docker and Kubernetes works together. Now, let me take you to the next slide where I am going to discuss Docker versus Kubernetes, right? So now, let me take the first feature, the purpose for Docker as a containerization, Kubernetes orchestration. So the main purpose of Docker is containerization. It packages your application with all their dependency into self-contained portable units called containers, right? Now, if I talk about the orchestration in Kubernetes, Kubernetes is all about orchestration, which managing many containers, possibly hundreds or thousands, across a multiple machine. Even it handles a scheduling, containers on the best node, restarting failed nodes, scaling up or down, and even managing traffic between the nodes, right? So this is for orchestration purpose. Now, when it comes for the feature called complexity, so Docker is simple, very simple for beginners. You only need a Docker file and Docker engine installed. And this is very much useful and good for local development and small teams. Same thing if I compare with the Kubernetes, it's complex, much more complex because it requires some multiple components like control plane, API server, scheduler, controller manager. Then we need worker nodes, right? Then we have networking, load balancer, persistent storage, right? So no doubt compared to Docker, these Kubernetes are complex, right? Now let me take a third feature called installation. So installation of Docker is easy. So one line install on any system. You can start container instantly. Same thing if I compare with Kubernetes. So here multi-step installation is required, especially if you manage it yourself. And here you will get some managed options like EKS, AKS, even more options you will get here. Then the next and very important feature called scalability. So scalability is limited here, and that too scaling is manual. You have to start continuously yourself or use a Docker Compose for a limited automation. Then at the Kubernetes side, you can see these are highly scalable. Kubernetes are highly scalable, right? Because it supports auto scaling and even cluster scaling, which automatically adjusts the number of pods, balance the workload across the node, and even it adds or removes the nodes dynamically, right? Now, let's move on to the next slide, the continuation of Docker versus Kubernetes. So here I have three differences, a Docker versus Kubernetes, where the first one is related to a feature called networking. So here in Docker, it's container to container, but in Kubernetes, container to clusters, right? fault tolerance is limited, and in Kubernetes it high because so as you know that Kubernetes which manages the pods, if one of the pod is get fails, automatically that will be replaced with the new healthy one, right? If I talk about the use cases, Docker is used for small application, and if I use for Kubernetes, so large scale applications. When I'm designing some large scale applications, at that time I'll go with the Kubernetes, right? Now, let me take you to the next slide where I'm going to discuss about the architecture comparison, right? So here at the first side, you can see the Docker architecture, and the next side we have a control plane, that to a Kubernetes architecture, right? So let me discuss first Docker architecture where I have the Docker CLI. So it's a command line tool which is used to interact with Docker, right? It sends a request to the Docker daemon, right? So now CLI doesn't build or run any container itself. It just tells the Docker daemon what to do. Okay. In the next step, in the second step, you can see I have Docker daemon. So this Docker daemon is engine or background service that actually builds, runs and manages the container, right? Even you can say that it listens for a Docker API request from the CLI or other clients, right? So this Docker daemon, it handles building the images, creating and running the containers, and even managing networks and values, right? Then we have container layer, right? Container layer is lightweight, isolated environment created from a Docker image where the application and its dependency run. So each container is built on top of the read-only images layer and adds its own read-write layer, right? Then we have Docker host also, the physical or a virtual machine where the Docker is installed that contains Docker engines, container, images, networking, and its value. So each container that runs an isolated processes within the host, right? So here you can see host operating system, the operating system that running on a Docker, whether it is Ubuntu, Amazon Linux, or any of the other operating system also. Then hardware, physical resources, whether it is CPU, memory, or disk, right? This is all about the architecture of Docker. Now, let me take you to the architecture of Kubernetes. So here Kubernetes is distributed. It runs across multiple nodes and has a control plane that manages everything. It's made up of two major layers, right? The first one is control plane which acts like a brain. Worker nodes, it acts like a body. Now let me take you to the components of this control plane. In that, first API server. It's a central communication point. So all Kubectl commands and internal components talk to the API server. Then we have scheduler. Scheduler that decides which node should run each pod based on resource availability. Now let me take you to the next layer called worker nodes. So in this worker node is like a mini Docker host that runs a container. So here we have Kubernetes. Here you can see in node 1 and node 2, we have Kubernetes. It's an agent on every node that talks to the control plane. It starts and monitoring the hosts, right? And here we have pod, right? Pod is smallest deployable unit in Kubernetes. A pod can contain one or more tightly coupled container. For example, we have application or sidecar logger. At that time, we can use pod. So all containers inside a pod shares the same network namespaces, shared storage volumes, shared lifecycle also. Let me take one simple example to understand this pod in a better way, right? So a pod may run nginx container as a web server, right? Then fluentd container as a log collector. So both run together inside on one pod now. So this is all about the architecture of Kubernetes. Even if I do one more time, the Docker versus Kubernetes architecture. So Docker scope is which runs a container in one host, but Kubernetes runs in containers across the many hosts, right? So here for Docker, we are going to use Docker CLI as a command, but here in Kubernetes, we are going to use kubectl, right? So scaling is manual in Docker, but scaling is automatic in Kubernetes. If I talk about the fault recovery, so it's manual restart in Docker, but here in Kubernetes, it's self-healing. That is nothing but auto replace failed pods, right? Now, let me take you to the next part, our next slide, that is CLI and tooling differences. In this slide, you can see CLI stands for command line interface. So Docker CLI is used to interact with Docker daemon. It manages individual container, images, and networks on Docker host. Kubernetes uses kubectl to interact with the cluster API server for managing pods, deployment, and even cluster resource. So here, Docker CLI, the purpose of this Docker CLI is used to build the images, run and stop the containers, manage the images, volumes, and network, and even inspect and troubleshoot the container. So actually, it interacts directly with the Docker domain, right? Running on your host machine. So now here in this slide, you can see some of the commands. Docker run image. That means it runs a container from this specific image, right? Then we have Docker image, right? Docker image that lists the available images. Then we have Docker pull. So if I want to download or upload an image from a registry, at that time I'll use Docker pull images. Then we have Docker build. If I want to build any image from a Docker file, at that time I'll use Docker build -t, right? So like this, we have different commands also, like Docker PS for listing the running containers, Docker stop to stop a running containers, Docker logs, view to view the container logs, Docker execute, which runs a command inside a container. So these are the different commands where I can use in this CLI. Now, let's move on to the next slide, a continuation of a Kubernetes, where I'm going to discuss some of the commands which are used in Kubernetes. So now, kubectl, right? Actually, it's pronounced as kube control in the command line tool to interact with the Kubernetes API server, right? So here, this kubectl is used for deploying and managing your workload. For example, we have pods, deployment, and services. Even it can be inspecting your cluster resources. Even for scaling applications, monitoring cluster health. For these use cases, you can use this. So here I have some commands. Kubectl get pod. That means here I'm going to list the resources, how many number of pods, services, deployment, everything which is available for you. Then kubectl apply -f. So now this apply configuration from a YAML file, right? Then kubectl logs a pod name. So if you want to view the logs of specific pod, at that time you can use this command. So like this, we have some different commands also, like describe, kubectl describe, which shows the detailed information about the resources. Then we have delete, kubectl delete, that deletes the resources. Then kubectl execute, which executes a command inside a pods container. Then we have kubectl scale, which scale the deployment up or down. So these are the different commands you can use in Kubernetes. So now if I do some comparison with Docker CLI and Kubernetes CLI, so the major difference, right? So Docker CLI, which talks about the Docker daemon, right? The scope is single machine. For example, I have a Docker, I'm going to run in a nginx runs container, which works in a locally. And kubectl. So kubectl talks about a Kubernetes API server. So what is this scope? Entire cluster, right? If I consider this simple example, kubectl apply -f app.yaml, which deploy your pod across the nodes. So this Docker CLI manages individual container. Kubectl that manages the group of container, that is nothing but pods, which is running on multiple servers. To understand in a better way, let me take one simple analogy, right? So think of an airport. So Docker CLI, the ground crew that prepares the plane, like fuel, passenger, luggage, everything is prepared by Docker CLI. Now Kubernetes, the air traffic controller who manages the dozens of planes across the multiple runway. That is nothing but cluster. So both are essential. One prepares the container, that is nothing but plane, and the other coordinate them safely at scale. Okay. Now let's move on to the next slide where I'm going to discuss about deployment workflow comparison. So here in this slide, you can see I have a developer and who is going to work on this Docker engine. Your container is ready. So first step is now you are going to build the application. So developer is going to build the application code, right? So developer writes the application code and Docker file that describe how to build the image, right? So in that, being a developer, you are going to define what is the base image, Node.js format, right? What all the dependency you have, the command to start the application, right? And in the second step, Docker engine pack the application into Docker images. So the developer uses some Docker CLI to create an image from the Docker file, right? For example, by using the command called Docker build for my application, right? Docker build -t my application. At that time, Docker engine takes all the dependencies, source code and libraries and bundle them into the container image. Then finally, what will be the output? A reusable image called my application, right? In the third step, you can see container that runs the application. Fine. So in this step, your app can be run anywhere with a Docker install, right? So now you can use a command called Docker run -d. You can provide a port number, right? So -d that runs in a detached mode and -p that maps the port number 8080 to the host 80 container. So this command starts the single container instance of your application, right? So now by using this Docker, it provides isolation. Your app can run in its own environment. Then portability. Same container that runs on any host with Docker, right? Now, let me continue with the next slide where I'm going to discuss about deployment workflow of Kubernetes, right? So here, developer writes a YAML code, that is configuration file, right? So instead of Docker commands, Kubernetes uses some declarative configuration in YAML, right? So let us consider I have one YAML file that tells the Kubernetes what image to use. For example, my app, what I taken the example in the previous slide. How many replicas to run? Replica 3. That means 3 replicas will be maintained. What labels to assign? Use the for grouping. And which port to expose? For example, port number 8. Right? Now, Kubernetes control planes read the configuration and scheduler the container. So now, it sends the YAML definition to the Kubernetes API server, which sends and then it stores into the etc cluster data. Nodes are the physical and virtual machines running workload. So here we have a Kubernetes scheduler that decides where, that means which node each port should run based on available CPU, memory and policies. For example, node 1 gets a pod 1, node 2 gets pod 2, node 3 gets pod 3. Each pod runs a one or more container based on your YAML definition, right? Now, pods are the smallest deployment unit. So now these pods runs in the container. Each pod launches your Docker container using a container runtime, right? So here every kubelet on each node talks on an API server, start containers, then report this status back to the control plane. So even here Kubernetes ensure that the desired number of pods are always running. If one fails, a new one will be launched automatically. Once everything deployed, Kubernetes automatically handles auto-scaling, adds pods when load increase, self-healing that replaces the crashes pods, rolling update the pods with zero downtime, and even rollback to revert to old version if any updates are available. To understand in a better way, let me take one analogy, Docker. So Docker is like a cooking a single meal in your home kitchen, that is fast, local manner. Kubernetes running an entire restaurant kitchen where you have multiple chefs, that is nothing but nodes. Automatic order assignment, that is nothing but scheduler, and replacement when chef leaves. self-healing. We are calling it as a self-healing. So that is the reason both are very essential. One focuses on building and running and the other managing and scaling. Right? Now, let's move on to the next slide. When to use Docker. You can use in small projects, local development, prototyping, and even testing. So when I'm talking about these small projects, so if you have a simple application, if your application is small, monolithic, and doesn't require a distributed scaling across the multiple server, so Docker alone is ideal. At that time, you can go with Docker, right? Let me take one simple example. You have built a portfolio website, right? So now you just need to run a one server or a virtual machine. So at that time, this is the best solution, right? So now let me take you to the next part called local development. So Docker gives developers to consistent environments across the machine. So you can develop locally in exact same environment that runs in a production, right? That eliminates work on my machine problem. For example, if you have three services like web with React, API with Node.js, DB with PostgreSQL. So using a Docker Compose, you can define all these services in a one YAML file and run them together, right? So now developers instantly spin up the full stack environment on their laptop. They can use the test code and even they can tear it down easily, right? Now, if I talk about the prototyping, right? So you have to do some continuous integration with some pipelines. So now continuous integration servers like Jenkins, we have GitHub Actions, AWS Code Build, even which often some Docker containers to run and build, test your isolated environment. Each build that runs a fresh container, no conflict, no leftover files, right? Now, testing. So testing here for learning and experimentation. If you are learning a microservices, API or DevOps tools, Docker, right? So at that time, this Docker is starting point. It's easy to install and help you to understand the containerization before jumping to orchestration. Finally, if I specify the strength of Docker means in that the first point will be Dockers are always lightweight in nature. Then portable, easy to learn, and there is no any complex setup. Let's move on to the next slide where I'm going to discuss about when you need a Kubernetes. So Kubernetes is essential when application require scalability, reliability, and auto management on multiple machines. So now you need a Kubernetes when your applications grows beyond a few containers. When you require a scaling, high availability, automation, load balancing, and even self-healing, right? Now, if I talk about the production environment, large-scale applications, let us consider when you have a large and distributed application. Kubernetes is designed to manage hundreds or thousands of containers running across the multiple nodes. That is nothing but servers, right? It automatically schedules and distributes a workload, so no single server is overloaded. If I talk about without Kubernetes means, you don't have to manually stop, like move container across the servers. Every time you have to do that. But with Kubernetes, control plane does this automatically, right? Let me take one simple example. I have a large e-commerce site, and in that I have 5 microservices like cart, user, payment, inventory, and shipping. Each service required 10 to 20 replica for reliability. So now Kubernetes will manage all the deploying, balancing, restarting, everything for the container as they require, right? Now, if I talk about the auto scaling, when you need auto scaling, right? Kubernetes includes the horizontal pod autoscaler, HPA, that automatically adjusts the number of containers, that is nothing but pods, based on your CPU, memory, or custom metrics, right? Even it ensures you always have enough ports to handle the current traffic and scale down when the load drops for saving costs, right? Without KS8, would have to manually run a new containers when the traffic spikes. With K8, it happens automatically, right? Let me take one simple example to demonstrate this auto scaling. Your backend application API handles approximate 200 requests per second normally. During marketing campaign, traffic spikes to 1000 requests per second. So Kubernetes that scales from 3 to 15 pods automatically, then back down after the campaign ends. Now, when it comes for the multi-node deployment, a multi-node deployment means your application containers are deployed and running across the multiple servers. That is nothing but nodes. Instead of just one, each node is physical or a virtual machine like our EC2 instance that run a part of your workload. Together, all nodes from a cluster that share the resources and workload. In short, single node deployment, all containers on a one machine. Multi-node deployment, containers distributed across many machines. Okay, now let me take you to the next slide where I'm going to discuss about alternatives to Kubernetes. So in that, Docker Swarm. So here, while Kubernetes dominates the container orchestration world, several other tools offer some similar functionality for specific use cases. In that, one of the tool is called Docker Swarm. So Docker Swarm built and maintained by Docker, and even it is easy to set up. So Docker Swarm is Docker native orchestration tool. It allows you to create a cluster of Docker nodes and manage a multiple containers across them directly using a Docker CLI commands, right? And this is ideal for small projects that need a basic clustering. And then it lacks advanced automation and ecosystem support for Kubernetes. If I talk about some features, native to Docker, no extra installation beyond the Docker engine. Simple setup and you can use. You can use the same Docker CLI commands like Docker service, Docker stack, Docker run, and even it provides load balancing and service discovery. Apart from that, this Docker Swarm support the scaling and rolling updates also. Now, when to use this Docker Swarm? You already use a Docker heavy and want lightweight orchestration, right? At that time, go for it. Then when you need a simple setup, then Kubernetes. At that time, you can use this Docker Swarm. Even in some cases, when you have a small to medium sized production environment, in that case also you can go with Docker Swarm, right? Now, the next alternative is ECS, AWS ECS service. ECS stands for Elastic Container Service. It's integrated with AWS architecture, easy to set up, and even it's integrated with other AWS services. Unlimited flexibility outside AWS. So here ECS stands for Elastic Container Service. It's a fully managed container orchestration service which is deeply integrated with other AWS services like EC2, Fargate, CloudWatch, and EMIA, right? So here, no need to manage a control plane or a cluster manually, right? So here it supports a different compute resources like EC2, where it's a self-managed service. Fargate is a serverless container service, right? So auto scaling is also one of the feature you can consider, and service discovery is built in now. Okay. Okay. Now let's move on to the next slide where I'm going to discuss about why Kubernetes dominates the other alternatives, right? So now Kubernetes has become the industry standard for a container orchestration because it's open, scalable, highly automated, and even extendable, right? And backed by massive community and ecosystem. Now, if I talk about the scalability in Kubernetes, right? So scalability means the ability to handle a growing workload, right? More container, more users, more traffic without performance degradation and manual intervention, right? So when I'm using a Kubernetes, what I'll get the advantage in terms of scalability. Here, Kubernetes provides a horizontal pod auto scaling. So Kubernetes will automatically adjust the number of running containers, that is nothing but pod, based on CPU, memory, or even custom metrics, right? Let me take one simple example. If CPU usage goes above 70%, so Kubernetes adds more pods automatically, right? Then we have cluster autoscaler, load balancing, global scalability, and even more concepts, right? Now let me take one simple example for this scalability. One more example you can consider. Let us consider you have one e-commerce company that experience heavy traffic spikes during this scale, right? So Kubernetes will automatically scales pod from 5 to 100, node from 3 to 10, and then scale back when the traffic decreases. And no doubt here we are going to save the cost and maintain the performance, right? Then next we have automation. So what exactly it means? Automation means the system handles the routine operational tasks like deployment, recovery, scaling, and updates without any manual efforts, right? So now Kubernetes, if I'm using this Kubernetes, I'll get the advantage like self-healing. If a pod or node crashes, Kubernetes will automatically replace it, right? For example, if you define the replica as 3 in YAML, so replicas are 3. If one pod fails, Kubernetes creates a new one to maintain that 3 desired level. And here it supports rolling updates and rollback. When you are updating the applications, Kubernetes replaces that pods gradually. There is no downtime, right? If the new version is fails, then it roll back to automatically back to the previous version, right? Next is extensibility. Extensibility is the ability to customize, extend, and integrate with other tools without changing the core system. Now, if you are using the Kubernetes, what advantage you will get here? Here, you will get the API-driven architecture. Every component in Kubernetes communication through open API. So, you can easily plug in your own tools, schedulers, or controllers, right? Now, apart from this, even we have operation framework in this extensibility. Operators let you automate the complex applications like database, right? The best example, MySQL, Kafka operator, you can consider here. It extends the Kubernetes automation to application level intelligence, right? Now, let me take one simple example here. Let us consider you have one DevOps stream that adds a PostgreSQL operator that automatically handles a database backup, upgrades, and even failover. There is no any manual work. So now, what we have the alternatives like ECS or a Docker Swarm are limited to customization. They don't allow to deep integration or any custom API, right? Now, the next point is community. So here, a strong open source community drives innovations, is available, and even it adds some new features and ensures a wide support across a cloud platform. Now, what advantage I'll get in terms of Kubernetes and that too for community point? So it backed by the Cloud Native Computing Foundation, that is CNCF, one of the largest open source foundation, right? Supported by Google, AWS, Microsoft, Red Hat, IBM, VMware, and many others. So here, thousands of contributors and vendors builds on the compatible tool like Istio, Argo CD, Linkerd, Helm. There are multiple tools are available. And here, it provides a massive learning resources, training, and certification also, right? So now it works on any cloud like AWS EKS, Azure AKS, GCP GKE, on-premises, or even hybrid environment. Now, let me take one simple example here. Let us consider you have a new company that releases some DevOps tools, right? That makes it Kubernetes compatible first because that's where the most production workload run today, right? Now, let me take you to the next slide where I'm going to discuss about some of the misconception of Docker and Kubernetes. So in that, the first one is Kubernetes replaces Docker? No, right? So Kubernetes doesn't replace Docker. It uses Docker to run your application. So Kubernetes did not remove a Docker support. It only replaced the runtime interface, not Docker image or functionality. So Docker was originally both a container runtime that contains a container, right? And a build tool that creates a container images. Now, Kubernetes uses the container, that is lightweight runtime from a Docker instead of Docker engine internally. But the Docker images you build are still fully compatible, right? Now, in short, you can say that Docker still builds the images. Kubernetes still runs them. They are teammates, not competitors. Okay? Now, let me take you to the next next misconception, you must choose either Kubernetes or Docker. Docker and Kubernetes complement each other. Docker builds the images where the Kubernetes manages and scales them. Okay, now let me take you to the next misconception. So Kubernetes is only for big applications? No. Kubernetes is designed to scale. However, it can also be used for small application. Now, Kubernetes can technically run any size of application from single small service to huge multi-cluster enterprise application, right? For example, if I have a small simple application, at that time you can use Kubernetes. If you have some growing multi-service application, large enterprise cloud native applications, at that time you can go with Kubernetes. Okay, now let me take you to the next slide where I'm going to discuss about future of Docker and Kubernetes, right? So Docker will evolve a go-to tool for creating and managing containers. So now Docker, the developers build and package a tool. Kubernetes, the production and orchestration platform. Now let me take the first point, go-to tool for creating and managing containers. So Docker will remain the primary tool for developer, right? They can build an application inside the containers, test them locally and package and push these images to the register like a Docker Hub or any ECR server. So now Docker remains the entry point for your container development. Now, OCI images will be compatible to Kubernetes. So, Open Container Initiative, a standard that defines how the container images should be structured. So, what exactly it means? So, now it means that the Docker images, Kubernetes containers can follow the same format, right? So, any image built with the Docker can run directly in Kubernetes cluster using the runtime like container or CRI-O. Fine. And the third point, reduced runtime role. So here Kubernetes no longer directly uses the Docker engine as its runtime. It now uses the container, which is a lightweight runtime extracted from a Docker. So now Docker runtime role is smaller, but its build role remains essential. Right? So this is the explanation for features of Docker. Now, let me take you at the next slide about Kubernetes, right? So, Kubernetes will dominate, like leading orchestration. Kubernetes has already become the global standard for a container orchestration, and even it compete tools like a Docker Swarm, Mesos, or even Nomad have a much smaller adoption. All major cloud providers like AWS, Azure, and Google Cloud uses the Kubernetes like EKS, AKS, and GKS are their base orchestration platform, right? And the second point is more automation. So Kubernetes is evolving towards self-managing system, right? Like auto-scaling, self-healing, automated updates, and rollback, right? So this feature Kubernetes releases will use some AI-driven automation to optimize a scaling resources usage automatically, right? Third point, IoT expansion. Kubernetes is expanding beyond data center into IoT. That is nothing but Internet of Things and edge computing. So lightweight versions like K3s or micro K8s can run on small devices such as Raspberry Pi or local gateway, right? Now, it expanding tools to simplify complex deployment. Kubernetes complexity has been barrier, but new tools are simplifying it, like Helm, simplify app development. Then Argo CD, automate the CI/CD pipeline. Then customize Lens, Rancher, easy cluster management. So now managed services like EKS, AKS, or GK can handle the control plane automatically. Okay, now let me take you to the next slide where I'm going to discuss about some pros and cons of Docker and Kubernetes. So let me discuss pros of Docker and Kubernetes in this slide. Okay. So if I talk about the Docker now, easy to use. Docker provides a simple command to build and run applications inside the containers, right? Now, great for beginners. This is also one of the advantage or pros you can consider because Docker is intuitive, that making it easy to learn the basics of containerization. It provides a Docker desktop and Docker hub with simplified testing and image sharing. Now, beginners can quickly understand how containers work before learning the orchestration tools like Kubernetes, right? Then a third point, quick builds and deployment. So Docker builds the applications quickly using the caching and layering. So you can deploy the updates just by rebuilding and pushing the new images, right? And then finally, a fourth advantage, you can consider the strong local development support. Docker lets you run the same stack locally as in production, which works great with the tools like Docker Compose for running multi-container setup. For example, application I have, database I have, then cache. So this is one of the example you can consider for pros of Docker, right? Now, let me take you to the pros of Kubernetes, right? So now it handles large distributed systems efficiently. Kubernetes can manage hundreds or thousands of containers across the multiple servers, automatically distributes the workload and even ensure the load balancing, right? Then a second point is called auto scaling. Even I was discussed in the previous slides also regarding the auto scaling. Kubernetes will automatically increase or decrease the number of running container based on CPU or memory or custom metric. No doubt here it saves the cost and maintain the performance during the traffic spikes, right? Now, self-healing. A third point you can consider for as an advantage in a Kubernetes, that is self-healing. If a pod crashes, let us consider now the pod is crashes. Kubernetes replaces it automatically. If node fails, pods are moved to healthy modes, right? So this is the one of the point you can consider for a self-healing capability in Kubernetes. As you can see, a fourth point, cloud agnostic and enterprise ready. So works across any cloud provider, whether it is AWS, Azure, GCP, or even on-premises environment. Open source and highly extensible with tools like Helm, right? Now, let me take you to the next slide where I'm going to discuss some disadvantages of Docker and Kubernetes. Let me discuss here. So now, let me take you to the first point of Docker. Not ideal for large-scale orchestration. So Docker alone can't manage the large distributed application across the multiple servers. And even it doesn't include a built-in auto-scaling, load balancing, or failover. So what is the solution? You have to use Kubernetes or Docker Swarm for orchestration purpose. And if I talk about the second disadvantage, it requires manual scaling and monitoring. So Docker doesn't automatically handle traffic surges. So you must manually increase containers or use some external monitoring too. Let me take you to the next slide, disadvantage of Kubernetes. In that, the first one is complex to learn and set up. Kubernetes has a steep learning curve. So you need to understand pods, services, deployment, nodes, and even YAML configuration. So setting up a cluster manually can be time consuming, right? So unless using the managed services like EKS, GKE, or AKS, right? So what is the solution? Then you have to use some managed Kubernetes services like EKS, Elastic Kubernetes Service. In Google, GKS. In Azure, we have AKS or lightweight version like K3 for learning. Then a second point, not for small projects, right? So here, Kubernetes is too heavy for simple or single container applications, which require some system resources and overhead that small application don't need, right? So these all are the disadvantages of your Docker and Kubernetes. Now, let me take you to the next slide where I am going to discuss about which one should you learn first, Docker or Kubernetes, right? As a beginner, start with Docker and learn how container works. build some images and run them, right? Then once you get some detailed information about the Docker, then you can move to Kubernetes to understand the orchestration and scaling. This is all about today's presentation. Thank you.